morning, this is Dr. S. Lakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is the lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Fourier series, wherein we are going to have a case study on real-time applications of Fourier series. Here we have our students of Information Technology Department, and this is Srinidhi, Pooja Shri, Raghavi, Vinushree and Nikhil Pradap to explain the concepts here. Firstly, we have the contents of Fourier series. First slide.
Here comes what is Fourier series. It represents periodic signal as sum of sine and cosine signals. It also breaks complex signals into simple components. It is also used in real world signals analysis.
Second slide.
And next, real-time context. Real-time signals like audio, temperature, voltages are irregular. Hence, it is irregular. We need a method to analyze them. By analyzing, Fourier series converts signal into frequency components.
So this is what we are going to implement here. This Fourier series converts signal to frequency components. This is our key point for the case study here. Okay. So this is what she explains as the key point in Fourier series analysis. Next.
Here I am going to explain mathematical formula of Fourier series. F of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity a n cos n x plus b n sin n x. Here in this formula a naught, a n and b n are coefficients.
So these are the coefficients of Fourier series which we have learned earlier, and separately we have formula to explain it. So what is the formula? It is, read the formula again.
F of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity a n cos n x plus b n sin n x.
So this is the formula to find the Fourier series. This is what we are going to implement. Next slide.
Next comes the coefficient formula. A naught is equal to 1 by pi integral minus pi to pi f of x dx. A n is equal to 1 by pi integral minus pi to pi f of x cos n x. B n is equal to 1 by pi integral minus pi to pi f of x sin n x. These
so
are
here, this is called as the sine wave, and this is called as the cosine wave, and this is called as the sine wave. So here the frequency components are split up into a naught, a n and b n. And next.
in this coefficient formula, these are not optional without calculating these. You don't have an actual Fourier series here.
We don't have actual Fourier series without calculating the actual a naught, a n and b n. So these are the main or key points for to frame a Fourier series. That is what is explained. Next.
So here is the example problem. Consider the signal f of x is equals to x plus 1 for minus pi to minus pi is less than x is less than pi. It represents a biased signal shifted waveform. It is seen in sensor data, audio signals with DC offset.
Next slide.
So here first step is to find a naught. A naught is equals to 1 by pi into integral of minus pi to pi into x plus 1 dx.
So this x plus 1 is the f of x which have been taken from the real time application. Go to the previous slide. So this is your f of x taken into account. This is your real time application here. F of x have been taken as x plus 1 which lies between minus pi to pi. Next slide. So this has been implemented in each of the Fourier coefficient formula.
Here we split it into this. Integral of x dx becomes 0 and integral of 1 dx is equals to 2 pi. Finally, a naught is equals to 1 by pi into 2 pi which is equals to 2.
So we have found the value of a naught, the first Fourier coefficient. Next.
So next we are going to find an, where an is equal to 1 by pi integral minus pi to pi x into 1 into cos of nx dx. And here we are splitting the component x into cos of nx, and it is odd. Therefore, the integral value becomes 0. Next we have cos of nx, and it is becoming 0 on integration. Finally, we have the value of an is equal to 0.
So how do we get this an to be 0 means we are just going to split this value into x of cos nx dx and 1 of cos nx dx. X of cos nx dx is an odd function. So however we integrate an odd function, it will become 0, and 1 of cos nx dx is on integrating with respect to x, and with the implementation of upper limit and lower limit, it will become 0. That is what we have explained here. She will explain here, and the final value of a is found to be 0. Next.
So next we are going to found the value of bn, where bn is equal to 1 by pi integral minus pi to pi into x plus 1 into sine of component x into sine of nx, it becomes even, therefore it contributes. Therefore, the sine of n of x becomes 0. On result, we get the value of dn is equal to 2 into minus 1 to the power n plus 1 divided by n.
So where this value will be coming? Existing value only on the integral x into sine nx. So this is an even function, so this contributes, which means its value is existing here. On splitting this into two integrals, the first integral will have the value, second integral will not have the value. That is what they have explained. And on simplifying with respect to the upper limit and lower limit, we will be having the value as dn is equal to 2 into minus 1 to the power n plus 1 divided by n. Next.
So next we have the final Fourier series, which is f of x is equal to 1 plus 2 into sine x minus of 1 by 2 sine of 2x plus 1 by 3 sine of 3x minus and goes on.
So here we found the values of a0, an and bn, right? a0's value is 1 plus an's value is 0 and bn's value is corresponding to the sine value. So on explaining and expanding it up to the n terms or infinite terms, we have 2 into sin x minus 1 by 2 to sin 2x like so. So this is our actual Fourier series here. So with this we are going to implement or analyze the signals here. Next slide.
Next comes the interpretation. We know how we come to know the values. A0 by 2 is equal to 1, which is DC offset baseline shift. Next, Dn becomes the frequency components, then higher n becomes the high frequency.
So this is what we interpret in the Fourier series. Interpretation means what we have found as a result or what we have observed as a result. So here A0 by 2 becomes the DC offset. We have studied one problem. In the problem we have a DC offset thing. That has been found as this A0 coefficient, and Bn is the frequency component, and the higher values of n will become as a higher frequency. This is what we interpret here. Next.
Here, a real world meaning. DC offset is a background signal that is biased, and sine terms are actual variations. In real system, it removes DC into center signal and remove high frequency to reduce noise.
So, in real systems, what this Fourier series does is it removes the direct current signals to the center signal, and also it removes the higher frequency signal. It reduces the from the higher frequency signal, the noise signals have been extracted and reduced. This is what this Fourier series does. That is what they are explaining here. Next.
Here the few applications. The applications are audio processing, signal filtering, image compression and electrical systems.
So these are the major 4 applications as we have discussed. Next.
So what here we conclude is that Fourier series becomes signal into components. Then Fourier series helps analyze and modify real world data. Next, essential in, which is essential, more essential in engineering.
So these are our conclusion as per our case study here. This Fourier series breaks the larger signals into simpler components. Second thing is it helps to analyze and modify the real world systems of the problems, and it is very much essential in engineering way of approach. So this is how we case study using mathematical model, which is called a Fourier series. Thank you.